and welcome Mindsetters to this session of Learn Extra Live for you guys. Yes, it's exam school, it's here, it's for you guys. You guys need to pay attention, you need to focus because we're trying to get you to pass those matric exams so you can get a good job and get a good education in university. You know, we're trying to help. But on that note, yes, we have a session to do and Tracy's here with me. So, what are we looking at today?
Well, guys, we're pretty much looking at whatever you need us to look at, okay? We have nothing planned per se. We're actually going to start by looking at a question that we got halfway through yesterday. Found a little bit of a mistake, so we're going to tweak it a bit. But the fun part is, Tracy's here too. And no, I don't mean me.
No, she's not gone crazy,
Tracy.
guys. No, there's another Tracy.
It's great. All Tracys are good science teachers.
Exactly.
So we're quite excited there are two of us. Obviously, guys, what that just means, I know we've got a work energy and power question lined up already. We've got a vertical motion question already from you guys from at home, but they've really got to be communicating with us. Otherwise,
that's the most important part.
Yeah, because we need them to tell us. It's crunch time now. Now it's got to be sorting out those problems. Because
Alright.
there's, in less than 24 hours, it's all over and physics is gone. It's done.
I'm even stressing for them.
Nah, don't be. They're fine. They've been watching the show.
You guys, you've been watching, so we'll
They're
be
cool.
fine,
Yeah.
So while you make your way across the board, Mindsetters, you know the drill. You need to get on the page, www.facebook.com/learn extra. Talk to me. Let me know what you guys are thinking. If you're lost anywhere, if you need help. Remember, the 3 T's are here with you as long as you keep up with your 3 P's. Getting that, because phones, pad, and your pens.
Oh.
So when you're writing down, you can talk to...
Cool.
So you know how that works. So make sure you get on the page, chat to me, let me know what you guys are thinking. We're trying to help you guys, so post on the page. But for now, we actually have something special for you. Tracy's going to explain what Curio is, so pay attention. Tracy, take it away.
Thank you, Ty. Guys, I'm so excited about this new platform that we've launched. Some of you actually saw about it yesterday and got onto the Curio page and onto the homepage, and we're doing the assignments. That is such a good idea. So Curio is a place where you can where we're going to upload from time to time assessments and assignments. They're all multiple choice, 10 at a time. Absolutely brilliant way to get practice and new questions. Okay, so what do we need you to do? It's run through Mixit, which I know you all know about, and also then doesn't matter if you have a smartphone. Okay, so what do you need to do? You need to go onto Mixit onto your phone. You need to log in, and then you need to go to add contact. So that's step 1. The next thing you need to do is you need to go to add contact manually because you're not looking for one of your friend's phone numbers. And then you're going to add in the ID in the text box, which is qa.ed.ge. Okay? Lowercase q, lowercase a dot, ed.ge, all lowercase, okay? So now you're going to go and put that ID into your... into the text box, then you're going to go scroll down to the bottom and you're going to send the invitation and finish. You're not done yet though. Then you go to the apps menu in your Mixit platform, okay? Don't go to the apps menu on your phone, go to the apps menu in the Mixit platform. Under general apps, you need to look for what you just typed in, qa.ed.ge, okay? Once you get there, click on it. Now you need to register. Okay, so when you register, you enter your name, and then you need to give us your mobile number, and you need to send it. Now comes the important part, because you're not quite finished. A confirmation SMS is going to be sent to you. Please don't worry, this is not going to cost you a cent. Mindset is sponsoring these SMSs, so we're very, very grateful. On that confirmation SMS, you are going to get a login code. You need to go back to your app, okay, and log into qa.ed.ge with the code given to you in the SMS. If you miss this part with the SMS and go back into the platform, you're actually not going to be able to make use of it, okay? Once you've logged in with the code, you're going to have the option to change your password if you want. That really is up to you, your choice, okay? But then you will be able to, once you've logged in, you'll be taken to the Curio homepage. Okay, so don't forget, qa.ed.ge, you've got to add in your contacts manually. Once you get to the Curio homepage, there are 2 assessments there at the moment. PSCI 2-3 and PSCI 2-4. That's an I, not a 1. The PSCI assignments is the 10 multiple choice that were put on the page yesterday, okay? And a whole bunch of you did that already. Well done. And the PSCI 24 is the one that was put on the page today. Okay, so they're 10 brand new multiple choice questions. And you all know John's had fun thinking up some of those. I had a quick look at them. Ooh, some of them are mean, but they're brilliant. But we need you to get this. What we've realized is that if you get to about number 3 in the multiple choice, you tend to finish all of them. You can't submit them until you've done all 10. Okay, a lot of you give up. Please don't. Even if it takes you half an hour, 45 minutes, that's fine, because that's the sort of time it's got to take you in your exam tomorrow to do the multiple choice. Work through them. Brilliant, 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 brilliant revision, okay? The answers to these assignments are going to be put onto the Facebook page at 6 o'clock tonight, okay? So yesterday's answers aren't available yet. Today's answers will be available from 6 o'clock tonight, okay? If you've done the question, there will be a star next to that question on the platform so you know and you don't have to redo it, okay? Go to the platform, download Curio, make sure it's on your phone, and get going with it. It's such a good platform, okay? No prizes, okay? So it's not a case of, well, the first one who finishes get whatever. No prizes for this, guys. But the prize is doing well tomorrow, and I think that's a brilliant prize for all of you, okay? Brilliant, brilliant, brilliant questions. Okay, so hopefully you've all got that, and you're going to get going with it. I think they got that.
Yes.
Lots of information. So, grade 12s, we need to go back. Yesterday, John was busy with a question, and he got stopped halfway through, and then we realized there was a little bit of a problem, but it's something you guys do, so I'm actually quite glad we can go over it again. So this is from Ntando. So Ntando, I hope you're watching. A 3-kilogram block slides at a constant velocity along of 7 along a horizontal surface, which is what's over here. It strikes a rough surface, causing it to experience a constant frictional force of 30. All those wonderful things. So we have velocity, we have friction, okay, and then, so the friction's here, so this is friction of 30, okay, then it slides 2 meters under the influence of this frictional force, we've got that, before it moves up, we like this, frictional ramp, inclined at an angle of 20 degrees to the horizontal as shown. Brilliant. So, first question. Oh, no, that wasn't the first question. There's the first question, and this is where things went a little haywire, okay? And John wrote a whole bunch of things, and it says, and that's not where he wrote it either. There we go. I'll get there eventually. Okay. The block moves a distance d up the ramp before it comes to a rest. Show by a calculation the speed of the block at the bottom of the ramp is 3. Now, there was nothing wrong with using the equation W net equals F net delta x cos theta, okay? This is where the issue is, guys. That what was done over here is that the force was put in as a negative. We no longer do that when we're using work, energy, and power. All right? Because we're looking at work done, and the reason why we're looking at work done is they wanted us to show that the velocity changes, okay? So you need to use that W net equals delta K. So that's really important, which means I need to know what W net was. The only force acting on it was friction, which is great, but we don't need the minus, even though, and this is what we don't do anymore, is we're not going to write that the direction to the right is positive. Because essentially what we're assuming is that the forward direction is positive, okay? But because of cos theta and because it's 180, now remember, the object's moving forward, friction acts backwards, okay? So friction is acting, and John drew a great diagram there, at 180 degrees, that is minus 1. So the difference here is we ended up with a positive answer, and it should have been a negative answer. So this one, oops, I wanted to do this. This answer should have been minus 60, not positive 60. Because if we put a positive here, which is what it should have been, cos 180 degrees, that's minus 1, it gives us minus 60 joules. Okay? Now that minus 60 joules actually does help us down the bottom here, because this is where things got a little bent out of shape, and I'm going to show you the proper answer, which is available on Facebook. I think it's here. There we go. Let's have a look. Okay, so here's it all done nice and neat, so you can see without all the messy stuff. Okay, final velocity is what we were looking for. The initial velocity was 7. The rest, this is just the maths issue over here. Okay, work it out for yourselves. It really is fine, and we get that the final velocity was 3, which is what we needed to show. Now, how did John know that by the time he got to this answer, he had done something wrong? Because he didn't get 3. The question said to you, prove that the velocity at the bottom of the slope is 3. Okay? He didn't get there. That means there was something wrong. Now, what are you doing in the exam where you go, okay, I can't actually see my mistake? You move on, okay? Because now the next question, first of all, if we look at it, says to us, draw a free body diagram. Not dependent on the question before, let's draw a free body diagram, okay? Showing all the forces acting on the block in a direction, now be careful here, parallel to the incline whilst it is sliding up the ramp. Be very, very careful with this one. They only actually want one force. My block is here. It is a frictionless. I'm glad I can speak English for you guys. It's a frictionless surface, okay? Nothing else is going to be pulling it up. Nothing's pulling it up. It's just been allowed to roll up, which is why it's eventually going to stop, which means the only thing acting on it is gravity. But they said parallel. That means you have to draw FG parallel. Okay? And remember, we would work that out. You don't have to put it into here. We would go FG parallel. That means we're going to have to use sine if we're going to need to use it. They're giving you a bit of a hint for the next question. So please, please be careful. Now, how would you actually draw this to show that you've got the right thing going? This is unusual because we would need to actually draw in the ramp. So you would draw in your ramp. Use a ruler, please. Okay, that's 20 degrees. Here's my object. Remember, it's got to be a dot. Line going down. FG parallel. Still, by now we're going, I needed to work out that 3. Maybe it was important. Let's see. Now they say to you, and I've sort of done a whole bunch of stuff here, calculate the distance D the block slides up the ramp. Okay, D. Well, I probably need to know that this was 3 meters per second. Grade 12s. This is where you go. All right, I didn't get the answer to 5.1. Fine, I didn't get the answer, but they told me it needed to be 3. That means you start this question by assuming that the velocity is 3. Okay? Now, unfortunately, I'm going to run out of a bit of time to actually answer this completely, but I'm going to show you where we're going. This, again, is a W net question. Okay? So W net equals delta K. We just drew the free body diagram, which means the only thing acting on here is force of gravity down. Now, I'm going to show you a different way of setting this out to what John did yesterday, and there's nothing wrong. I just want you to see that you can do it in one step, which means I would need to go FG parallel delta X cos theta would then be equal to final minus initial for my potential, for my change in kinetic energy. FG, we just wrote it down, is sine, so that means this is mg sine theta. Delta x is d, that was the distance they asked us for. Cos theta we'll deal with in a second. This is a half mvf squared minus a half mvi squared. You've actually done all the hard part in terms of the signs. So let's quickly go back here and go, it's a 3 kilogram block. It comes to a stop once it gets up the top of the block, the ramp. So that means this is going to be 3 times 9,8. The ramp was at 20 degrees, so it's sine 20 degrees. D is what we're looking for. Now, cos block is moving up the ramp, gravity is moving down the ramp, it's cos 180. It's cos 180 degrees. We know it's 3. Once it gets to the top of its motion, it's 0. Okay, this is 3, and this would be 3 squared. Okay, now let's work out what, so 3 times 9.8 times, where's it, sine 20, gives me 10,06, that's how we're going to write it in. Okay, and cos 180 is minus, so I know that's what I'm going to get. So over here, this gives me, there we go, minus 10,06 times d. And that's going to be equal to 0 times, and now so half times 3 times 9, which actually I can't do in my head today, times 3 times 3 times 3, which is 13 and a half. I could have done that if I tried, but it's okay.
These things happen. These things happen.
That's why we have calculators. Okay. Now this is what I wanted you to see. I am going to get a negative answer on the side there, okay? But D's also got a negative in front of it, which means D's going to work out to be a positive answer, because now we're going to divide that 13.5 by 10.5, oh, sorry, 0.5, and we get 1,34. So it's going to go up 1,34 meters, and we're done. You could have worked out FNet on its own, like John did yesterday. There's nothing wrong with that. Then put it into the equation at the end. Okay, so I hope you guys all got that. Nice questions, one of the more difficult ones. And I think, Ty, it's time for a break.
Yes, it is. So mindsetters, keep doing what you're doing. Keep chatting to me on the page. Keep on posting. If you're having any problems, let me know, because we're trying to help you. So if you don't help yourself by posting on the page, kind of makes us not help you.
Redundant?
Exactly.
Yeah, good
But
work.
anyway, so to prevent that, make sure you just talk to us. But for now, we'll see you after this break. And welcome back, Mindsetters. Wow. Guys, I just want to say congratulations, and I just want to say thank you for using the page to this. Like, literally, you guys are maxing it out, which is awesome, guys. Keep on sending in those areas that you're having problems with. And don't forget, you can also email us at our help desk if you need also, like, really big questions that you need help with. Don't forget to email helpdesk@learnextra.co.za. No, mindset.co.za, my mistake. But yes, keep on talking to us, keep on chatting to us. But yes, we've done a little magic trick, and we swapped out Tracy's, so you probably noticed right now. But yes, Mindsetters, keep on tuned in, keep on posting, keep on chatting to us. And yes, we've got a show to do so. Tracy, take it away.
Thanks, Ty. Welcome, everyone. Grade 12s, we are going to be looking at some more questions on vertical projectile motion. And we're going to be tackling a question that John looked at yesterday, and we left as a challenge question to you. So let's turn and just have a look at what the question was asking of us. Layla is in the basket of a hot air balloon, moving downwards at a constant speed, that constant speed of 4.5 meters per second. She is 9 meters above the point where Johnny kicks the ball vertically upwards. The ball has an initial speed of 12 meters per second. That's how hard he kicks the ball vertically into the air. Johnny is standing 80 meters above the ground. He's on a cliff. Ignore the effect of air resistance. So let's move down and see how what the question was. There he is, Johnny kicking the ball, and he's kicking the ball upwards. And they ask us, calculate the maximum height the ball will reach above the ground. Now, when you do this, it's critically important that you choose a direction. So here, John chose direction up as positive, and that's vitally important because from there, all of the vector quantities would need to have a direction as well. And very often students get confused where they have one value as positive and then they forget a negative and they get all mixed up. So choose a direction. Then the second idea is to make a list. So here we are going to work out the question asked us, the maximum height, and I'm going to write that as delta y. Delta y, the height above the ground vertically. So delta y is our question mark, final velocity is 0. I want to just sketch this picture for you. There's the ball, it's being hit up, and at this point, at its maximum height above the ground, that value is 0. When something reaches its maximum height above the ground, it will always stop instantaneously for a very, very tiny minute, for a tiny moment. But its final velocity at the max height, or I'm going to write here at the top, is 0 meters per second. Meters per second. His initial velocity was, the ball's initial velocity was 12 meters per second up. Acceleration is 9.8 meters per second down, and so you could also write that as negative 9.8 meters per second. And we do the calculation, equations of motion, calculate the answer, and work out that delta y is equal to 7.35 meters above the ground. That means the 7.35 meters above the ground, well, the ground was actually a cliff, which itself was 80 meters above the ground. So in total, the height above the ground was 87.35 meters. Moving on, this was the challenge question now. Layers in the basket, again the same information. And they ask us, will Layla be able to catch the ball in flight? Show all our calculations. So let's make sure we've got all the information. We have her starting in the hot air balloon, there she is, at 89 meters above the ground. Why 89? Well, the 80 meters of the cliff, and she is 9 meters above the cliff. Check that. She is. There it is. She is 9 meters above the point where Johnny kicks the ball, and he is standing 80 meters above the ground. Then we know something else about her. She is moving at a constant speed of 4.5 meters per second. That's the hot air balloon's initial velocity, and it's constant velocity, so it will be final velocity as well. The next piece of information we've interpreted the graph. Oh, that was the ball. We've just got it in here. 87.35 is its meters above the ground at max height. Now, for Layla to catch the ball, the time that she is moving down, the ball is moving up. So for her to catch the ball, they need to be at the same place at the same time, basically. And so we need to work out the time that the ball is moving up and the time that she is moving down, and see if they come across one another, see if they pass one another. So let's get ourselves started. I want to recommend to you that you choose direction. So choose direction always as your first point. I'm going to choose up as positive, up as my positive value, and we're going to work with the time. So I'm going to write my list again. Delta y, A, V final, V initial, what else do we have? Time is equal to. I'm going to first work out the time for the ball, then I'm going to use that same time for the ball reaching its maximum height to work out the time that Layla will be moving down in the hot air balloon. So delta y, Do I know that value? I do. It was 7,35 meters to its maximum height. So from the ball going up to its V final at the top. Okay. Acceleration. If I've chosen up as positive, we're working with negative 9.8 meters per second to the minus 2. V final for the ball. At the top of its motion, remember it will have 0 final velocity. So this is 0 meters per second. I know it's hard to think about, but that ball, when it reaches the top, will be momentarily stationary because then it's going to start to fall down. So at the top, with its change in direction, it's got a 0 meters per second velocity. Initial velocity was 12 meters per second. And the time is my question mark. Have a look at the information. You need to go and choose equations of motion. Because we've worked out another value already for delta y, we could probably work with quite a few equations of motion. I'm going to choose the simplest one, and that is V final is equal to V initial plus A times T, the first equation of motion. Let's just extend the page slightly and keep going down. 0 is equal to, initial was 12, plus A is negative 9.8 multiplied by T. And let's put those in brackets just to show you substituting. Recognize acceleration is down, that's the force of gravity, causing it to accelerate downwards at 9.8 meters per second. Moving things around, we can have negative 12 divided by, take across to the other side, negative 9.8 is equal to t, and you come out at t is equal to 1.2 seconds. That is the time it takes for the ball to reach max height. I'm off the page there, but time for the ball to reach the maximum height. Now we can work with that time and go to the next idea of where will Layla be in that 1.2 seconds? Remember, whenever you get a time value, it must be a positive value because time is scalar. Time doesn't go backwards. So for the time, you need to make sure that as you go along to it, if you haven't chosen direction correctly, I haven't chosen substituted direction correctly, you might have a problem. So that's a good watching out point. Let's see if we can go down a little bit further on our page and work out for Layla where she's going to be. For Layla, or the hot air balloon, she will be going at a constant velocity. So again, I've got down as negative and up as positive. So I'm going to stick with that. And I'm choosing the standard equation for constant velocity. You could plug in values with acceleration equal to 0, but for constant velocity, I think that's the easiest. We're going to work out what her displacement will be as she moves down. It would be negative 4.5, y negative, because she's moving down, multiplied by the 1.2 seconds is equal to the delta y. And I have it over here. Her delta y for that time frame is equal to negative 5.51 meters. That means in the time that the ball is going up, she is going down by 5.51 meters. So where will she be? Well, recall, initially the balloon, and let's just sketch this balloon here quickly. She was at 89 meters. Now she's moved down by 5.51 meters, and so we can subtract those values. So 89 minus the 5.51 meters is equal to, and it gets her to being at 83.5 meters above the ground. We still haven't answered our question. Where is she, and will she be able to catch the ball? Well, in order for Layla to catch the ball, she needs to be in a position where she can be in contact with the ball. So the ball is going up, and it went up to a maximum height. Let's find it here. What was its maximum height? Its maximum height of 87.35 meters. She, in the same time as that ball is going up, is going down and gets to 83.5 meters. So she will pass the ball. As the ball goes up, she's going to be going down. So she could have an opportunity within those 1.2 seconds to catch the ball. So yes, she could catch the ball then. If she missed the ball, for example, maybe she wasn't watching and she missed the ball. That ball goes up and comes down. Okay? She will still be moving down, and her speed going down was 4.5 meters. At the top, the ball was 0 meters per second. But as it falls down, it's going to be accelerating. It's going to be going faster and faster. Why? Because it's being pulled down by gravitational acceleration, pulled down by gravity. So it's going to be accelerating here at negative 9.8 meters per second squared. So that ball falling down is going to speed up, and at some point, as it continues to go down, it will pass her again. So she could have two opportunities to catch the ball. Let's finish that. Well, that question's pretty much done. A very interesting question, a very, very good question. Let's move on to look at some of the multiple choice questions that I know people were struggling with in the Curio set. Very, very quickly, let's go across to some of these questions. A ball is thrown perpendicularly into the air and reaches its maximum height after 6 seconds. Let the direction up be positive. What is the velocity and acceleration of the ball after 6 seconds? I want you to write in here at the top. At the top of its motion, it still is going to have an acceleration, and that's very tricky. But gravity hasn't disappeared. Gravitational acceleration is still pulling down, and if up is positive, it's going to be negative 9.8. I want to just move this down. You will notice that all of these acceleration values have a negative in them. What is the velocity going to be? Well, at the top, the velocity is equal to 0. So none of those two could be okay. It has to be option D. The acceleration is equal to negative 9.8, and the velocity is equal to 0 meters per second. The last multiple choice question, which follows directly from this, is to consider the same, I'm moving it up, the same ball, but what happens to it after 7 seconds? So it's gotten to the top, and now 1 second later. Acceleration is still negative, so it's got to be one of those options. What is its velocity? Well, its velocity is now negative because it's falling down. So your option here must be A, where the acceleration is negative 9.8 meters per second squared. The velocity after 1 second, it's accelerated, and so it's at 9.8 meters per second, but it's down. So it has to be a negative value. That's all we have time for in this session, but I'm sure there are plenty of questions coming in.
Like, the page is so full. So full. Like, I'm literally scrambling, like, down, like, okay, trying to help out wherever I can. Mindset is keep on posting on the page. But for now, we're going to take a quick ad break, so make sure you don't disappear and keep using the page. See you soon. And welcome back, Mindsetters. Like, yes, you guys really want to pass this exam because I'm seeing so much activity on the page. Guys, thank you. Keep on posting. Me and a couple of other of the Mindset team are going to be on the page helping you guys out. So if we don't get all the questions to Tracy, we're going to get them answered for you on the page. So make sure you pay attention to what you just posted. But for now, don't forget to also check up on Curio, get yourself logged in, use it. It's for you guys. It's simple. It's easy. We're trying to help you out. And on that note, this is where I hand over to Tracy. Tracy, take it away.
Oh, thanks, Ty. Guys, with the Facebook page, please don't worry that Ty's answering your questions. Sorry, Ty. We love him, but he's a musician.
I'm trying.
I know, Ty. But we actually do have a couple of science teachers working in the background, answering your questions, making sure we can give you good answers to that. So keep going, guys. Obviously, we're not going to be able to do all your questions live, but we're going to answer as many as we can. Now, apparently, a lot of you guys have been requesting this question, and I'm actually quite glad. It's from the 2008 paper, so yes, it is 4 years old, but it is a stunning electricity question, and I get to do it, and I love electricity. So, it says to you, a circuit is connected as shown below. We'll look at it in a second. The resistance of R is connected in parallel with the resistance 10 ohm resistor is unknown. When switch S is closed, the reading on the voltmeter decreases, now this is important, from 45 to 43. Let's write that in straight away. So what that means is your EMF is 45 volts, okay, because that's the big one. Your external voltage is 43, let's really, oh man, let's make it so you can read it. Your external is 43,5. We might need those values, so we're going to keep them there, okay? And then they told you the internal resistance is 0,5, so that's great. I'm not going to look at the question just yet. First thing we're going to do, you guys know I like doing this. We are going to get some colors, and let's start with yellow. Doesn't matter which way around we go. So the current gets to this point. Okay, it's now going to split, so we change the color. Let's go to green. Let's make the 10 all green. I'm hoping you can see that, which also means that this ammeter becomes green. Let's change it to, I don't know, let's make it purple. And, I think I've just got we just got rid of it altogether. Let's not change it to purple. Let's change it to, I don't know, orange is good. Well, sort of. You know what we'll do? Let's do this. There we go. Okay, you get the point. Okay, I could be here forever. Our colors are not playing ball with us. That's just rude. Irrelevant. Okay, point is, it splits. We don't know what the value of R is. We cannot assume R and the 10 ohm are equal. Do not do that. R and the 10 ohm are in parallel with each other. The 12 is in series with the 0.5 ohms, which also says to us that all the current goes through the 0.5 ohm, all the current goes through the 12 ohm resistor. It splits here. The important thing is that this ammeter gets whatever current goes through that 10 ohm resistor. Okay. First question. Calculate the reading on the ammeter A. Show all your calculations was worth 8 marks. The next question on this was, find the value of R. Grade 12s. What this means, and this is why you got to skim the rest of the question, is you can find calc A without finding R. Please be careful here, because what a lot of you do, and it is the easier way around this, is you find R, you then calculate A, and you get your marks for A. Brilliant. Then in the next question, where I've now said to you, calculate the value of R, you just go R equals so many ohms, and you lose all the marks for it. Now, some of you are going, but why? I calculated it in the first question. You calculated it in the first question, not in the second one. The marks for that calculation are in the second question. You must do it again. Okay? Be very, very careful there, grade 12s. I don't want you to lose marks for stupid reasons. Okay, so let's think about this logically. And we're going to say to ourselves, okay, to calculate current, the easiest way to do it would be to go, well, R equals V over I. The current through this, so this would be the 10 ohm resistance. We want I, we would actually need to know V parallel. So pretend we have a voltmeter over there. Can we find V parallel? That's the question. Let's go back and see what we have. Okay. Well, I know that we have, okay, V parallel, we got to go, well, I know what V lost is because, or V internal, that we can work out because it's the difference between those two, so that would be 1.5. Okay. Not sure if that's going to help us, but what we do know is if I had to take my external voltage, it would be equal to my parallel voltage plus the voltage over my 12 ohm resistor. Getting a bit closer. So now we go, okay, how would I find the voltage over the 12 ohm resistor? Well, here once again we've got R equals V over I. I need to know what total current is because I know R. This is what I'm looking for. Somehow I've got to find that. So now let's look back at another one and we go, oh, hang on, you're all screaming at me, I hope. The internal resistance gets all the current. I know internal voltage, I know internal resistance, and if R equals V over I, I can find I. So this is how we work it out. We're going to use the internal resistance to find the current. We're then going to take that current, put it into the equation with the 12 ohm. We're then going to use the voltage from that one in this equation, okay, which then gives us the parallel voltage, which we can then put into that equation. It's worth 8 marks, okay? This is not a simple one equation question. 8 marks. I have to do, it's actually going to turn out to be 4 equations because I've got to show everything that I'm doing, but that's okay. So let's start at the beginning, okay? V internal is what the first thing we're going to work out is, okay? So we're going to write that in, and we're going to say, well, my V internal, because we want to work out the current, is going to be my EMF minus my external, so we write it in. Okay, so it's 45 minus 43.5, which gives me 1.5 volts. That's great. We've got those marks now. From V internal, we want to find I. So we know little r is V internal divided by I. So this is going to be 0.5 equal to 1.5 divided by I. I'm actually going to put this as IT because this is total current that I'm looking at. So that means that I total is 1.5 divided by 1/2, 3 amps. Okay, so we've covered this part and this part. Okay, now that I've got the current, I'm going to put it into that equation over there. Let's use a different current color so you can see it. And grade 12s, you know what? Please do it like I'm doing. Don't jump from side to side and say, because it becomes very confusing for your marker. Okay, so for the 12 ohm resistor, we want to know what its voltage is. We know, make that straight line. We know that we know total current, so that's 12. V over here is what I'm looking for, and that's 3. When we take it over, we get 3 times 12, which is 36. Okay, so that's 36 volts. Remember, then I said to you that to find the voltage over the parallel section, your parallel voltage is going to be your external voltage minus the 12 ohms. So that's 43.5 minus 36, which gives me 7.5. So now we go all the way back here, and we go, look, I know R, I know the 7, and yay, we can find I. Okay, making our lives very easy here. And now we go, well, my R, and this is the 10 ohm that we're working with, is V parallel. I can call this I because this ammeter didn't have a name. So that's 10 equal to 7.5 divided by I. So that means I is 0.75. I, let's do this, equals 0.75 amps. Not so bad, hey? You just got to take it step by step. Next question. Now, let's just, okay, a lot of stuff hasn't, because we've got a new question, but what we would do now is I would actually write in here that V parallel is 7.5 volts. I know that this is 0.75 amps. I know that total current through this is 3 amps. We had worked out that the 12 volts over here, voltage over here is 36. Okay, and you know the external and the internal EMF, okay? Guys, I'm just writing in all the information I found along the way because I might need it. This is all information that I don't need to work out again. It's done. It's in the question above it. Now it says to you, determine resistance R. It is only worth 3 marks, okay? This one isn't as difficult as it looks. You are welcome to work out what the total parallel resistance is, then go 1 over RP. I just think the math there becomes a little hairy with the fractions, so I'm going to show you another way around, because you need to recognize that my current split up. So if 0.75 amps goes through the 10 ohm, we need to say, well, the 0.75 plus the current through R must give me 3. So in fact, the current through R is going to be 2.25 amps. We just need to show how the calculation is, because now I know voltage, because it's in parallel, so the voltage is the same, and I know the current. That's easy enough. R equals V over I. So let's set it out nicely. So my total current is going to be equal to the current through R plus the current through the 10 ohm resistor, which is I. We could have just left that as I, okay? So that's 3 I plus 0.75. And grade 12s, remember, you have more than enough time. You really can take the time, set it out. Please don't look at the mark allocation and go, well, it's worth 3 marks. I should be able to do it in 3 lines. No, doesn't always work like that. Now we want the resistance of R. So we can go, well, R is going to be V parallel divided by I going through R, which is 2, no, it's 7.5. Divided by 2.25, and we get 3.33 ohms. Not so bad, hey? And then the last part of this question, which is the type of question you all hate, says, how does the reading on the voltmeter change if R burns out? So R disappears. Give a reason for your answer. Now, and I'm going to do it as in shorthand, just so we've got time, so we don't run out of time, okay? I'm removing a resistor out of parallel, which means total resistance is increasing, okay? Which means total current is decreasing, which then means my internal voltage also decreases, because V internal equals I times R. And if my internal resistance is decreasing, that means the internal voltage is decreasing. That means the external voltage is increasing. Okay, so the external voltage, ooh, now it just looks like something out of a sci-fi movie. Your external voltage is going to increase, and this is the reading on the voltmeter. Okay, so your answer is the voltmeter reading increases. Why? Because the total resistance has decreased, current decreases as a result, so the internal voltage also decreases, so external must increase because your EMF stays constant. Okay, and time? It's time for a break.
Yes, I think so too.
Yeah.
Before their brains melt out their ears, because
Yeah,
it'll
little.
be just too much information, and then it gets all hot in there, and then you cause friction between the lobes, and then
He's
see,
learned
fine.
some important words along the way. I like it.
Exactly. So
Well done, sir.
mindset is make sure you stay tuned, keep on posting on the page. But for now, we'll see you after this break. And welcome back, Mindsetters. Woo! I need to even stretch out my fingers because you guys are keeping me busy, yo. But yes, Mindsetters, keep on using the page, keep on posting, keep on letting us know what you guys want to cover, what you need to cover, and keep on posting, talk to us, and don't forget to also email us at the help desk if you really need something specific that you need help on. Also, use the page and the help desk at learnextra.co.za. Don't forget that. But on that note, this is where I hand over to Tracy. Tracy, take it away.
Thanks, Ty. So we're going to be tackling a question now on the photoelectric effect. This was emailed through this morning, and so we're going to tackle this question. And I want to really encourage you, as you're going through some more questions on chemistry for your chemistry exam later on, start sending those emails through now, and hopefully we can tackle those questions as well. So let's turn and look at this question. It comes from a past exam paper. A group of learners performs an investigation to compare the effect of two types of radiation on the emission of photoelectrons from zinc. So we have here zinc metal, and we're investigating two types of radiation and seeing if they will emit photoelectrons. So if the electrons will be emitted because of these little packets of energy or photons hitting the zinc plate. They place a zinc plate on top of a disk of a negatively charged electroscope. A negatively charged electroscope. Now, an electroscope is used in electrostatics specifically to look at detecting a charge, and we can, you probably will have looked at an electroscope in the past. The two types of light, ultraviolet and red light, are shone alternatively, so at different times, onto the zinc plate as shown below, with the electroscope fully charged in each case. So ultraviolet light is shone on this negatively charged electroscope. We monitor what happens, and then the electroscope is recharged again to negatively charged, and then red light is shone onto it. So let's have a look at the diagram that they give us. There we have our zinc plate. We have this radiation, which we've been told is either UV radiation or red light. The disc, the metal bar of the electroscope, and here we have some gold leaves. Now, the gold leaf electroscope will cause the leaves to separate or split and move apart from one another because of the repulsion of electrons. So if you'll notice here, this electroscope is negatively charged, and they've indicated those little electrons on the page showing that they are the gold leaf is separating or moving away as far away as possible because of this overall negative charge. There's repulsion between the like charges, between the electrons and the electrons. So there's our electroscope. These are now the observations, and you will get a practical-based question, something like this. So you do need to be able to interpret and understand what an unseen question would be. They record the following observations. So these are almost like their results. For ultraviolet light or UV light, the gold leaves collapse, move back down. For red light, there is no effect on the deflection of the gold leaves. So they don't deflect at all. They stay separated. Write down an investigative question for this investigation. Now, if you're being asked to look at an investigative question, you're kind of being asked to show what's the purpose of this. It needs to be, number one, it needs to be a question. And number two, it needs to be specific in terms of the relationship between the dependent and the independent variable. So let's consider some options as a question. Maybe we can say, which type of radiation, the type of radiation, would that be independent or dependent variable? Think about that for a moment. Which type of radiation will cause electrons to be emitted from the zinc plates? Question mark. That is what I'm trying to investigate. So it's my investigative question. The two things I'd like you to notice here, the type of radiation, that would be one of my variables. That is specifically my independent variable, because it's something, variable, because it's the one that I'm controlling. I shine the UV light on, I shine the red light on, something that I control, will cause electrons to be emitted. This here is my dependent variable. Okay? So notice you're asking a question and you're linking the independent and the dependent variables. The next question. Again, the same information. Let's head down. Explain the observations made for ultraviolet light. So for ultraviolet light, the gold leaves collapse. Let's just undo that. The gold leaves collapse. And the question is, why? Why would the gold leaves collapse? Well, let's have a look here. If I've got UV light has a very high energy light, and that's going to allow electrons to be emitted from the zinc plate. So point number one, the UV light causes electrons to be emitted from the plate. Point number two, these electrons that are all over, sorry, let's try that again. These electrons that are all over the electroscope, because it was negatively charged, will now be able to spread out further. So they will move away and they will rush up, and I'm just putting little arrows there to indicate that the electrons in the gold leaf would move upwards to where there's now a shortage of electrons on the zinc disk or the zinc plate. And so I'm going to write in here shortage of electrons at the top, and so the electrons will move up because electrons are free to move in a metal, so they would move through. And that would mean that there would be less negatives on the gold leaf, which means that there would be less repulsion, and so those gold leaves can move back towards one another. And that is why. The next question, sorry, did we miss anything there? No, I think that's it. The next question. What conclusion can we make, can be drawn from this investigation? And the conclusion is that electrons were emitted for the UV light because the gold leaves collapse. So I'm going to write in here electrons emitted there. But if there was no effect on the deflection of the gold leaves for the red light, there was no emission of electrons, and so no electrons emitted off the zinc plate. And that would be your conclusion. So simply that only ultraviolet light or radiation will emit electrons off the zinc plate. The next question from this. The following safety precaution is printed on the ultraviolet light source. Safety is a big concern, and specifically with radiation. Different radiations have different penetrating abilities. And so you would know if you go out into the sun, the UV light from the sun can burn your skin because it can penetrate the deeper layers of the skin. So that's one of the issues that we need to be concerned with here. A health risk associated with overexposure to UV light. We are considering skin cancer or damage to the skin. I'm going to even put high likelihood of skin cancer or risk of skin cancer, increased risk of skin cancer, and also damage to the eye, and it can cause cataracts. The higher the energy of the radiation, the higher the penetrating ability. So something like an X-ray would be able to penetrate even further and would be needed something much thicker, like a lead, thicker lead layer to stop it. For example, gamma rays would have even higher energy and so require a lot greater barrier to prevent them going through. The next question. Define the term work function of a metal. Now they give us a whole bunch of information. The learners have access to the following information. The work function for zinc, the frequency of ultraviolet light, so I'm going to write there F, and the frequency of red light, also F but for red light. The work function of a metal. The work function of a metal is the minimum energy. It is an energy value in joules. It's the minimum energy required by an electron to be emitted. By emitted, I mean sent out and released from the surface the metal's surface. And different metals will have different work functions, but it is an energy value. So it's the minimum energy required for an electron to be emitted from the metal surface. We're now going to use this information in a moment. Name one type of electromagnetic radiation, so anything else in the spectrum with a higher frequency than UV light. You've got options here. You could either say X-rays or gamma rays. Both have a higher frequency than ultraviolet light. Now we get to start to calculate some things. The learners have access to the following information. They have the work function of zinc. That is the, and I'm writing here, minimum energy. Remember, that's the minimum energy required for an electron to be emitted. The frequency of ultraviolet light, the frequency of red light. Use a calculation to explain why red light fails to emit photoelectrons from the surface of the zinc plate. So here we need to work an energy calculation. There are two equations that you could work with. I'm going to start with this one. E is equal to H times F from your data sheet. And let's just, sorry, hold on a moment. Let's just get our page bigger here. H stands for Planck's constant, and Planck's constant is given to you on your data sheet. You need to find it and be able to work with it. I've got it on the board here. And we are looking at red light. So E is equal to 6.63 times 10 to the negative 34 multiplied by the frequency of red light, which was this one. So 4.29 times 10 to the 14 hertz. And we plug those values in and work out that the energy comes to a value of 2.84 times 10 to the negative 19 joules.
Yes. Do you think?
Almost there. We haven't quite finished answering the
Alrighty.
question.
Okay.
The idea is that we need to take this number and compare it to the work function of zinc. And have a look at those two values, and you'll notice that, if I just shift this down, you'll notice that the value here is less than the work function. And so that is why electrons can't be emitted. Ty, over to you.
All right. So mindset is, whew. I know that's a lot of information, and these sessions are coming quick, fast, and in a hurry. But yes, mindsetters, keep on posting on the page, keep on talking to me, keep on letting me know what you guys are thinking. And yes, we'll see you after this break. Welcome back, mindsetters. Yes, don't forget your 3 Ps, your pens, pads, and your phone, and make sure that you get on the page and utilize the page. Talk to us, and mindsetters, don't forget, if you see a mindset in trouble, help them out. But yes, do not also forget Curio. Get yourself logged in, use it. It's for you guys. It's going to help you guys a lot. So, hey, I'm just too old to be on it. But anyway, you can be on it. That's the whole point. I would use it if I could. But anyway, moving right along, mindsetters, keep on getting those questions in. We're going to attack them as many as we can, so let us know. But on that note, Tracy, take it away.
Oh, thank you, Ty. In fact, we're now going to go on to a momentum conservation of energy question, which we actually haven't tackled in a while. And I just have to say thank you to the mindsetter who sent this in. I have never seen this question before. It is stunning. I really like it. So, and also to Lindsay, thank you for putting it onto the board for us. Says to us, John wants to get his friend Peter to a height of 2.8 meters above the ground to reach an apple in a tree. They connect a swing to a high branch in an adjacent tree. Clever boys. The bottom of the swing X is at a height of 1.2 meters. We're, of course, assuming that the rope is long enough. We have to make this assumption. Peter has a mass of 45 kilograms. Ignore any frictional forces. Yay! We can ignore friction. We like that. Bonus. Now, what they do is they give you all the information on the diagram, which is great. We don't have to put anything extra in there. Now it says, state in words the law of conservation of mechanical energy. Guys, big key here, mechanical energy. That means you cannot state the law of conservation of energy, which says that energy cannot be created but simply transferred from one form to another. That's normal energy. Conservation of mechanical energy states that in a closed system, the mechanical energy of the system remains constant. Okay? It remains constant. You do not need to say magnitude. You do not need to say direction because, of course, energy is a scalar. So it only remains constant in magnitude. That doesn't mean it changes form. Remember, mechanical energy refers to both kinetic and potential. Great. Next question. Oh, no, that's not what I wanted. Next question. There, where did it go? Okay, no, I've missed a page. There we go, 6.2. Says to us, calculate the minimum speed with which John needs to push Peter from X to reach the apple in the tree. We have to make a very big assumption here. And that is when John gets here, his velocity is 0. So he just gets enough, gets to the apple, and then can swing back down. So they want to know, what is VI? They've just asked you the conservation of mechanical energy. They've given you the hint. That means we need to use the conservation of mechanical energy in this question. So watch here. What that conservation says to us is, my mechanical energy at X is equal to, okay, so at point X is equal to mechanical energy at the apple, at the next part, okay? I'm not using top and bottom because I don't have an object that's going from the top to the bottom. The swing isn't from a 0 position, though we could work that out in another way if we really wanted to. So at x, at the apple, that's great, because remember, the whole point of mechanical energy is anywhere in its motion, the mechanical energy is the same. So that means we're going to add the potential at point x plus the kinetic at point x. If you're using EP and EK, it's fine, okay? And that's going to be equal to the potential at the apple, probably should have used an A, but it doesn't matter, plus the kinetic at the apple. So now we go, okay, this is all the science, by the way. We're not getting even into the maths, which means we're going to go mgHx plus a half mvx squared, which is going to be equal to mgh at the apple. And we said that by the time it gets to the top of its swing, its velocity needs to be 0, so that kinetic energy is 0. Make sure you substitute it in. Now we can put in all the values we know. So m is 45, g is 9,8, at height is 1,2. Okay, ooh. The board doesn't like it when we go too fast, so that's squared, and this is going to be 45 times 9,8 times 2,8. Okay, I don't need to put the naught in anymore because it's plus naught, so it's fine. And guys, just to save a little bit of time, because I need to get to the last question of this, and I've got a whole bunch of other stuff I need to tell you, you guys can work this out, and Vx works out to be 5,6 meters per second. Okay, now it's a math problem. So this was worth 7 marks, 6 out of 7 marks just at that point. Okay, now it's maths. One step at a time, use your calculators. Last question now says to you, when Peter returns, John of mass 55 kilograms, so we've got an extra person here, also grabs and holds on to the swing. So John doesn't stop. Peter doesn't stop. He now picks up John as he goes along. Calculate the speed of the combination immediately after John has grabbed the swing. That means Peter is coming down here and his velocity is actually 5,6. No frictional forces, which means by the time he returns to his original position, he's got to be going at his original velocity. Okay? Original position means original velocity. We have John and Peter colliding. Collision means momentum. So that means we've got to go from the fact that we know total momentum before equals total momentum after. Before the collision, Peter and John are 2 different objects. So the mass of Peter plus his velocity is going to be equal to the mass of John plus his velocity. Afterwards, they're one object, they grabbed onto each other. So we're going to add their masses together. We want their final velocity. They're all going to go in the same direction. So Peter was 45 kilograms, going at 5,6. John wasn't moving. Okay, he probably should have got out the way, but that's okay. 45 plus 55. We want the velocity. This actually works out to 252. It's equal to 100. And my velocity is 2,52 meters per second. It makes sense that it's slowed down because we've added mass to it. Okay? Grade 12s, if you had got the question before wrong, we carry down that error. What have I done without actually specifying it is we've actually said that Peter's direction is original direction. Okay? Why didn't I put a direction in words? Because the question said calculate the speed of the combination, okay, the 2 of them together. If they had said to me, calculate the velocity of Peter and John after they've been grabbed onto each other, then you would have to say in Peter's original direction, away from the apple tree, anything to that effect, okay? The nice thing is the direction with positive and negatives wasn't really that important because John wasn't moving. So one of your original velocities was 0. That makes life very, very easy for you. Okay, so grade 12s. We have covered a lot of work, okay? But now you've got to listen up because I know we haven't covered everything you want in the live show. And a lot of you have got a lot of questions. A lot of you have questions on electricity, electrostatics, electrodynamics with the right hand and the left hand and all those rules. Guys, please stay tuned for the next 2 hours, okay? There are recorded shows. We have shows on that are going to cover electrostatics, electricity, electrodynamics. So for the next 2 hours, we're going to be able to, hopefully, they'll answer your questions. Okay, there's only so much we can do. Unfortunately, I know you're struggling with those sections, so make sure you stay tuned to the live show. To the pre-recorded show. If you want to interact with a live show, that we're now going live on the radio stations, okay, which is the community radio stations in Limpopo, KwaZulu-Natal, and the Eastern Cape. For those of you who live in Gauteng and the Western Cape and all the rest of it, and you go, well, that doesn't help you. Of course it does, because if you go onto the Mindset website and you click on live stream, you can hear those broadcasts through your computer. Okay, you can have a live stream of those radios, that radio broadcast. I'll speak English for them. What do you think?
Yes, that would be handy.
This is why I don't have a voice for radio. Yeah. Anyway, you can click on the live stream. You will get the live radio broadcast through your computer if you do not live in Limpopo, KwaZulu-Natal, or the Eastern Cape. Okay, live streaming radio show, also a live show. So that means you can also interact, get your questions answered. And I know you're going to radio. You can still get a lot of good work done through the radio stations. Okay, it's a brilliant platform. I know it's not as visual. It's still a very, very good platform. So remember, next 2 hours, electricity, magnetism, basically. And then if you need to see this again, or you have friends who missed the live show, remember we have a repeat at 10:30. Okay, it is late, but we do have a repeat at 10:30. So if you need to go and watch the repeat again. I'm not sure I'd want to see me again, but go watch the repeat again. Okay, stay tuned. From tomorrow, grade 12s, we are starting chemistry revision. Obviously, physics is over, so don't ask us physics questions. Please do not send questions in about your paper from yesterday. It's done, it's written, it's over. Okay? From tomorrow till Sunday, we are going to do live chemistry revision. In fact, 5 o'clock tomorrow, live grade 11 revision. Grade 11s, we haven't forgotten about you, but grade 12s, you better tune in because it's stuff you will need for Monday. Okay, and that's me done.
Yes, so why don't you just take my job while you're
'Cause I
at it?
can.
I'm joking. So Mindset is, thank you for joining us. Make sure you keep on using the page, keep utilizing it. It's for you guys. Mindset is, I just want to say thank you for joining us. Don't forget Curio. Don't forget to check on the events page for all the exam school timetables. And this is where I then sign off and say thank you and see you next time. Cheers.